Hello students. In the school, I was doing this chapter that is interference of light. Okay, I've completed few of the topics. So the topics which are left from this chapter, I will be doing online itself. The topic which is left is fringe width. Now, this is the diagram from Young's double slit experiment. Over here, there is a light coming from through this one hole over here. Small slit is there in this S. From here, the light gets split and there are two different holes, S1 and S2, two parallel narrow slit which are very close to each other and equidistant from S. The light waves from S reaches S1 and S2 in the same phase. Now, according to Huygens principle, S1 and S2 acts as a new light source from which secondary wavelets originate. These two sources serve as a pair of coherent light source because wave emerging from them originate from the same wavefront and therefore maintain the constant phase difference. So if they are traveling from S, they maintain the same phase difference till it reaches S1, S2 and further. These wavelets form interference fringes. This wavelet coming out from these two holes, two slits, they form a pattern which I have already told you. They form fringes which will be bright and dark fringe in this particular screen. So what we are trying to find is, we are trying to find the width of this particular fringe which is formed at this screen. Now over here, CO is the bisector of S1 and S2 which meet at the point O. At this point of the screen, the secondary wavelet from the coherent sources S1 and S2 meet in same phase. So S1O is equals to S2O. So we are taking a point P on the screen. Distance X from O. Distance of P from O is X. Now in the previous class, I have already found the path difference, that is S2A. Now what you can see over here is light reaching from the distance of S1 to P and S2 till P is different. So we are drawing a perpendicular over here such that S1P is equals to AP. This distance and this distance becomes equal. Okay, so the difference in the path between S1P and S2P is this particular difference. So this difference is S2A. This is known as path difference. So this S2A was equal to XD divided by D. This derivation is done in the class and I hope you all have the notes. Now from this one we are finding the position of the bright fringe. So we are trying to find the position of the fringe over here in order to find the width. So fringe, the definition of fringe width is the distance between two consecutive bright and dark fringes. So fringe width is denoted by beta. Now path difference, this one is a multiple of wavelength. So it is a multiple of wavelength, such as M is integer such as 0, 1, 2, which is equals to XD by D. Next, in general, the position of the mth bright fringe. Mth means any fringe. Okay, M can be anything. So position of the mth bright fringe will be M lambda is equals to X M D divided by D, or XM. X means this distance, okay, from O to, from central point to any point. So XM is equals to MD lambda by small d. So this is XM. This is the position of the mth bright fringe. Next, what you have to find is I'll continue it over here. Position for M plus 1 bright fringe. So position for M plus 1 bright fringe will be from the same equation, xm plus 1 is equals to m plus 1 d lambda divided by d. So this is the position of xm plus 1 fringe greater than this fringe. So we have got mth fringe and m plus 1 fringe. So now to find the fringe width, whatever we do is we have to find the difference of these two. So fringe width beta is equals to xm plus 1 minus xm, which is equals to m plus 1 after putting the values. D lambda by small d is equals to m d lambda by d. Now first of all we need to multiply whatever is there with this minus m d lambda by d. Now this to gets cancelled. Beta is equals to d lambda by d. This is the fringe width. Okay, this is the fringe width. Now next is angular fringe width. The angular position of fringe width. Angular fringe width denoted by theta. Okay, theta is angular fringe width. So similarly what we have to do is we have to find the theta m, that is the mth position of the mth bright fringe. So this is the position of mth bright fringe. Theta m is equals to xm by d. Which is equals to xm by d. Now putting the values of xm, what we can write over here is m d lambda divided by d divided by this d, which is equals to d and d gets cancelled, m lambda by d. Now the position of theta m plus 1 bright fringe, which will be m plus 1 lambda by d. Okay. After cancelling d and d we get this. Now fringe width, that is theta, which will be theta m plus 1 minus theta m. So is equals to m plus 1 lambda by d, sorry, this is small d, d minus m lambda by d. So after multiplying in the numerator you can write d, over here it will be m lambda plus lambda minus m lambda. So theta is equals to lambda by d. This is the angular fringe width. Okay. Angular fringe width is independent of the position of the screen. Now next I will draw the intensity distribution curve. Okay, the next one is intensity distribution curve. Now as we know, if two interfering wavelets have the same amplitude A, okay, it has got amplitude A, then the bright fringe will be of intensity. We have already written this equation. Maximum intensity, equation for maximum intensity was K A plus A square. If both are of same amplitude, it becomes K twice A square, which is 4KA square, and this remains constant. Now I minimum will be, or my minimum intensity will be this. So if A and A is same, this becomes 0. Okay. Thus in Young's double slit interference pattern, among all the fringes are of equal width, the bright fringes are all of equal intensities, while the dark fringes are of all totally dark, that is 0 intensity. So if I draw a diagram for intensity 1, intensity increases this way. This side is the path difference. Over here is minimum 0. Okay, now the first one will be of I max, that is intensity curve having the maximum intensity. This is I max, which is of intensity 4 Ka square. Now comes minimum over here. This is minimum part. This will be 0. Intensity is 0, so it will be totally dark and it will be in the same line. Again, this is dark fringe, this is bright fringe. Again comes the bright fringe of same amplitude and same intensity. Okay. This is lambda. Okay. Lambda is the wavelength, so it will be lambda. So over here, one cycle completes, so that is one cycle will be completed over here, so it is lambda. Second, for the second cycle, again dark, then comes the bright. Then this over here will be 2 lambda because it completes second wave cycle. Similarly over here, this side will be minus lambda. Sorry, not this one. This side will be minus lambda. Again, if you continue, then it will be 2 lambda. Similarly, it will decrease this side. Now, from here, what we can understand is intensity distribution curve are of same amplitude. Maximum intensity has got this amplitude and minimum intensity has got zero intensity, that is of 0 amplitude. Okay, so this is an intensity distribution curve among the Young's double slit fringes. Okay, now with this we are almost towards the end of this chapter. So there are a few topics which you can study on your own. First one is coherent source. You have to understand the concept of coherent source. Okay, the coherent source is source of light having sharply defined phase difference that remains constant with time. So two sources of light having the same phase difference, okay, so which remains constant with time, that is coherent source. So you go through the detail of coherent source from the book itself. Another topic which is important is condition for sustained interference of light waves. So to obtain a sustained interference of light waves, there are conditions. So you need to go through 2 of the following conditions. Okay, so this topic are important and they are just simple notes you can find in the book itself. You can go through the book. Okay, with this we come an end to this chapter. In the next class I will be starting another chapter, that is diffraction of light. Okay, thank you.